Good morning and welcome back to Oscillations. In this session, we are discussing about the simple pendulum. Let us consider a body of mass m which is connected to or which is tied to a light, massless, inextensible string fixed to a rigid support S. And such an arrangement is called simple pendulum. Now, O represents the mean position. O represents the mean position. T represents the length of the pendulum. T represents the tension in the string. When the bob is oscillating over its main position, two forces are said to be acting on the bob. Bob A is the one which is tied to the lower end of light, massless, inextensible string. And mass of such a bob is taken as equal to m. Now, the two forces acting on the bob are the gravitational force which is acting vertically downward, that is mg, and the tension in the string which is acting towards point S, which is along the string. At any instant of time, the displacement of the bob from the mean position is given by theta. Theta represents the angular displacement. Theta represents the angular displacement of the bob at any instant of time. Now the weight of the bob mg is resolved into two components. One will be mg cos theta, which is along the length of the bob, which is along the length of the pendulum, and the other one is mg cos theta, which is perpendicular to the length of the pendulum. Now, from figure, F is equal to minus mg. F is in this direction. As both are oppositely directed, we have F is equal to minus mg sin theta. If the angle theta is very small, then this relation becomes equal to minus mg theta, as shown here, minus mg theta. Also, the arc OA is equal to L sin theta. The arc OA is equal to L sin theta, but for small angle again, sin theta becomes theta, therefore OA is equal to L into theta. But OA is nothing but equal to x. Therefore x is equal to L theta, or theta is equal to x by L. Therefore the above force becomes F is equal to minus mg into, in place of theta I write x by L. But we also have the restoring force F as equal to minus k into x. Therefore, equating these two, minus kx is equal to minus kx is equal to minus mgx by L, x and x gets cancelled, minus gets cancelled, and therefore the remaining quantity is k equals mg by L. Plus mg by L. This is plus mg by L. Since both the negative signs gets cancelled. Or we also have F is equal to ma. From Newton's second law of motion. Therefore, A is equal to F by m. F is equal to minus mgx by L whole divided by m. Therefore, it is mgx by ml. Gets cancelled again. Therefore, it is minus g by L into x. Or otherwise, g by L is a constant. Since g is a constant, and L is again a constant for a given pendulum. Therefore, G by L remains the same. Therefore, A is directly proportional to minus x. Acceleration is directly proportional to x. And we know that this is a simple pendulum, right? This is a simple pendulum. And if this is the displacement of the particle moving in this direction, then this will be the direction of the acceleration. Acceleration is directly proportional to negative of the displacement, right? If this is acceleration, then this will be displacement. A equals A directly proportional to minus x. A is acting in this direction. And the period of such oscillation is given by t equals 2 pi into root of m by k, or that is equal to 2 pi into root of x by a, where x represents the displacement in this case and a represents the acceleration of the particle, or t equals 2 pi into square root of L by G, since A equals G by L into x, or A by x is equal to G by L, or x by A equals L by G. Therefore, t equals 2 pi root L by G, where L represents the length of the pendulum and G represents the acceleration due to gravity at the place. Now, from these expressions, it is clear that period of oscillation of a simple pendulum is independent of mass of the bob. From this, it is independent of mass of the bob. So it only depends on the length of the pendulum and the acceleration due to gravity at the place where we are performing the experiment. A simple pendulum with a time period of oscillation of 2 seconds, if capital T is equal to 2 seconds, then such a pendulum is called seconds pendulum. A pendulum with a time period of 2 seconds is called a seconds pendulum. Thank you.